Somewhere in the 4 billion year history of life, something absolutely incredible happened. The universe, in a way, became aware of itself. This wasn't a single eureka moment. It was a slow, gradual dawning, one of the greatest mysteries there is. And that's the journey we're going to take today. So, let's get right to the heart of it. The big question is this: when did simple information processing, a cell just responding to a chemical, turn into actual subjective experience? When did it start to feel like something to be alive? To put it simply, when did the lights turn on? And this timeline, wow, it really puts the sheer scale of this mystery into perspective, doesn't it? We've got a pretty good idea when life began, way back 4 billion years ago. And, well, we know we're conscious today. But that huge, vast question mark in the middle, that's what we're here to dive into. To even begin to unravel this, we have to start at the very, very beginning. So let's kick off with section 1, from chemistry to sensing. We're going to look at the absolute basic tools a life form needs before anything like an experience is even on the table. It all begins with something called sensation. But hold on, we're not talking about feelings yet, not even close. At this stage, it's just a simple mechanical process. An external signal, say a sugar molecule, bumps into an organism and triggers a response inside. And the key part is that response isn't random. It's adaptive. It helps that little guy survive. Okay, let's take a tiny bacterium, like E. coli. It's a fantastic example. First, its receptors sense some sugar. But here's the really clever part. It uses a kind of chemical memory that lasts just a few seconds to compare how much sugar there is now versus a moment ago. Is it getting better? If the answer is yes, it adjusts its little tail and swims straight for the food. It's literally a decision-making circuit without a brain. Which brings us back to that nagging question we're going to keep asking. I mean, this is amazing information processing, right? You've got sensing, you've got a little bit of memory, and you've got adaptive behavior. But is there anyone in there experiencing it? Most neuroscientists would say probably not. This is just really, really sophisticated clockwork. The lights are most likely still off. Okay, so if simple life is just clockwork, how do we move beyond that? Well, that brings us to section 2, the first integrated minds. For those lights to even have a chance of turning on, life needed a serious hardware upgrade. It needed a way to connect different parts of the body and start combining information in much more complex ways. And then, along came the neuron. Showing up around 700 million years ago, these cells were an absolute game changer. Just think of them as living biological wires. For the very first time, a signal from, say, the front of an animal could be zapped to the back in an instant. And even more important, neurons could connect to other neurons, forming networks. This is the birth of integration, and it changes everything. So what can you do with these newfangled networks? Well, for starters, you can build much better sensors. Take this, an eye spot. It's just a simple clump of proteins that can sense light. It can't see a picture, not at all, but it can tell where light is coming from. And that allows an organism to build a very simple map of its world. Light is that way. But then, around 520 million years ago, evolution took a truly massive leap with the image-forming eye. We're talking about a complex organ with a lens focusing light onto an array of sensors, all of their signals being integrated into one coherent picture. All of a sudden, the world wasn't just a vague chemical soup anymore. It was a landscape filled with objects, predators, prey, and places to hide. The world snapped into focus. Now, seeing the world is one thing, but to truly experience it, you have to remember it. Memory is the glue. It's what takes a series of disconnected snapshots and stitches them together into a continuous movie. It's what creates a you that moves through time. And how does that happen at the biological level? Well, it all comes down to a really elegant, simple rule. When two neurons are active at the same time, say one for the smell of a flower and one for the sight of it, the connection between them physically gets stronger. It's a famous saying in neuroscience: neurons that fire together, wire together. And that's pretty much the physical basis of learning and memory. Okay, so now we have integrated senses and we have memory. What's the next big piece of the puzzle? That brings us to section 3, the emergence of self. Because, let's be honest, all the experiences in the universe don't mean much if they aren't happening to someone. An experience needs an experiencer. And the self isn't this one thing that just pops into existence. It seems to be built up in layers.
You probably start with the bodily self, that basic feeling of, yep, this arm is part of me. Then comes the perspectival self, the understanding that I see the world from this particular spot. After that, a narrative self can emerge, the sense of being a continuous character in your own story. And finally, maybe the deepest layer, the reflective self, the simple, profound awareness that I know that I am.
The key to building that narrative self is something really special called episodic memory. This is so much more than just remembering a fact. It's the ability to mentally time travel, to put yourself back in a moment and relive it from your own point of view. You're not just recalling information, you are literally inhabiting a memory. And get this is not an exclusively human club. Recent studies are just fascinating. Scrub jays, for example, remember not just where and when they hid some food, but even who was watching them when they did it. And rats will mentally replay routes they've taken and even pre-play routes they might take in the future. They're casting themselves as the main character in their own mental movies of the past and future. Okay, now we're at the deepest layer, metacognition. This is where consciousness turns its gaze back onto itself. It's not just about having thoughts, it's about being able to think about your thoughts. This lets you know what you know and, maybe even more importantly, know what you don't know. In experiments, animals like monkeys and dolphins and even rats will actually pass on a difficult test if they think they're going to fail. They have a sense of their own certainty. And with this final layer, with a self that is actually aware of its own awareness, I think we can safely say we've arrived. The system isn't just mindlessly processing the world anymore. The lights are fully on, and for the first time, it really feels like someone is truly home. But even after tracing this entire, incredible 4 billion year story, a huge, profound mystery remains. And that's our final section. Consciousness, the hard problem. This is the ultimate question that, frankly, science still has no real answer for. The philosopher David Chalmers framed it perfectly. He said there are easy problems and the hard problem. The easy problems are about how the machine works. How do neurons fire to tell red from blue? It's incredibly complex, but we can imagine figuring it out. But the hard problem? That's different. It asks, why is all that processing accompanied by an inner feeling? Why is there a subjective experience of redness at all? Why isn't it all just happening in the dark? This question, of course, leads us right to the cutting edge of our own technology. If consciousness is just what really complex, highly integrated information processing feels like from the inside, well, does it matter what it's made of? Could a machine built from silicon instead of carbon eventually wake up? Right now, I think most researchers would tell you probably not. Today's AIs, as powerful as they are, tend to work like a one-way street. Information flows in a straight line. But our brains are a chaotic mess of feedback loops, with information constantly circling back, changing itself, and influencing other processes. Now, new AI designs are starting to copy these more brain-like structures, but the question of whether a machine could ever be truly conscious, that remains wide open. So what do you take away from all this? Maybe it's this final thought. After billions and billions of years, a little bit of matter on a small rocky planet organized itself in just the right way that it could look back out at the stars and wonder where it came from. If consciousness emerged from the universe, then we're not just visitors looking in from the outside. We are the universe experiencing itself. And that, right there, might just be the most profound story of all.